Welcome to my video presentation of Design Lab number 3, Real World Solutions using Logic Gates. So, a brief intro. Ever since the invention of streetlights, it has brought various benefits to mankind that are essential to daily night activities. So, streetlights has provided a wide range of uses such as security. It can reduce crime rates and reduce accidents that happen in an area. So, it is not a common thing for streetlights to not operate to what, if left at such state for a long period of time, may bring harm to the community and to the people around. So, our first task, capture the problem, zoom to the actual problem. So, these are the street lights found in my street, in my community. So, as you can see at the left, it's the comparison, and day and night, right? There are street lights that are off, there are street lights that are functioning. This is another street in our area. Next, the block. As you can see, no street lights are being fully functional. The place there is very dark. Only the household lights are being utilized for vision. So it's really a dangerous place. So as you can see, this is the map of our barangay. I have mapped out the streets that are very poor in night light. As you can see, this long line, this is where we live. So our street does not have functioning street lights, and this is the other one. This is the other one, which the other street that has no street light, poor street lights, very poor night vision because the street lights are not functioning. So as additional content, I felt that there was an improvement in the way how the lights are operated, as they are switched on manually just in a control center. It's a building near in one of the streets. So the concern led me to formulate another solution for this problem. So we'll get to that in a while. Dig deep. Number 2, dig deeper by knowing what causes it and why until now it is still a problem. So maybe I just felt like maybe there's insufficient budget. Another connection of mine told me that there was given less importance and priority as to the other projects of the LGU. And why is it still a problem? The project is still unfinished, despite the streetlights are there being they were placed there for a very long time and they are not doing their functions. So it might be the reason for many future bad activities that might come around the area. So number 3, know how this certain problem affects the people or the community. So it affects the people in a way that it loses its purpose to provide protection, security, and improve night vision. It may lead to various crimes, especially in streets with poor visibility, increased risk to accidents that may make the community, the people around it, less safe due to lack of night vision. So what solution do you propose? Design a system using logic circuits. So I proposed a centralized automatic streetlight system in which it turns on if it's already at nighttime. It works with a daylight sensor that will capture first the sunlight, then if the daylight is absent, and then it will turn off. Daylight sensor will work as the core for this automatic system. This is applicable to all streets that have the same structure for streetlights. In our case, this is around our vicinity. I also included a feature in the form of emergency light, in which it is a solar-powered LED that will turn on if the street light system in the street does not work. So I improved a solution that what will happen if the street light is out due to power outage, due to malfunction. This is where this solar LED emergency street lamp comes through. So I will explain further in my design. As you can see, sorry if it's a very large design. So this design is designed for the whole street, as mentioned in the map a while ago. So I'm gonna go. This is the street lights. They are clumped in total, and there are the three main switches. I will explain that in a while. So this is the design when the street lights are on, and this is a design when the street lights are off and the emergency lamps are activated. So I will further explain it in my simulation. So basically, it just means that using logic gates, I am able to come up with these outputs. First, with the use of these three inputs, then I will formulate the configuration so that it will lead to these outputs. These are the street lights. So next, it's also the same. Using logic gates, will make these emergency street lamps light up in the absence of these clumped up street lights, in which there is an backup for the night vision, so that the people may feel safer. So this is a zoomed in version. As you can see, I can explain clearly. So these are the three inputs: the manual switch, the power, and the daylight sensor. So these are usually turned on every time, unless there is a power outage. In the switch case, there is a tampering. It has been tampered in this daylight sensor. It will act as the automatic, the core of the automatic design. It will turn off. It will be at logic 0 when it is nighttime. As you can see in this picture, it is at daytime, so all of these bulbs are at logic 0. All of these are off. And as additional features, I also have this vehicle alarm, which are placed at the intersection. Let me just quickly navigate. These yellow lines, these are the intersections. I plan to place them. They provide a certain additional security feature that will help the people from if ever they want to cross the street, or whatever, they have children. It works in many ways. It acts as an alarm buzzer. It will be detected by the motion sensor on the ground if a vehicle is approaching. And so for the other side, so this is the road, for example. These are the edges of the road, the intersection leading to the intersections. There is a vehicle alarm buzzer in every edge of the road. So an additional feature will be in the design added, which is a vehicle alarm buzzer, which will send a buzz when a vehicle is approaching. With the movement of the vehicle detected by the motion sensor, the buzzer will notify a person whether a vehicle is approaching towards the intersection. So welcome to the simulation part of the video. So this is my overall design. I'm gonna zoom it out. So as you can see, this is the street that has three sections. So there are roughly 16 street lights per section, for a total of 48 street lights in this street alone, which is divided into three sections. So first, I'm gonna do simulation, in which I will divide the simulation into three situations, and of course explain my design as the simulation is going. So first is the first situation. We have three inputs, right? We have the manual switch, which is we have the power, and we have the daylight sensor. So this daylight sensor is what makes my design being turned into an automatic centralized streetlight system. So first is I'm gonna show the situation when it is daylight. For the first situation, I'm gonna have so it's daylight, right? So this daylight sensor will capture light, so it will be turned on. As you can see, it is now at logic 1. So as you can see, my design, the bulbs are all turned off because it is daylight. So in this, I'm just pan out the sections so you can see clearly. So that's it for the daytime. Since it's daytime, the lights are turned off. So I'll go to my next situation, which is uh, the nighttime. It's nighttime already, so this daylight sensor won't capture any light, so it will be turned off, and thus it will be at logic 0. So as you can see, in the second situation, it is nighttime, and all these switches are on. Considering this manual switch is just turned on, it's not been tampered. There is also power. There is no power outage, and as you can see, daylight sensor is off since it's nighttime. So the street lights, the clump of street lights are turned on, as you can see, for the middle section and for the east section. So we have the street lights working, and it is at nighttime situation. So then for the next situation, I'm gonna have the emergency street lamps being turned on, so it's still at nighttime. And what if there is a power outage? So the switch for the power will be at logic 0. So as you can see, the emergency street lamps are turned on because this will be the substitute whenever there is a power failure. As you can see, I'll pan out on the sections of the street. So there you go. That's the three situations I presented. So what I'm gonna add now is another part of my design, which is the motion sensor, for which the vehicles approach. So it doesn't matter if it's day or night. So it's connected to the power, and it runs in power, and this push button acts like a buzzer. So when I push this, there's a motion detecting movement of vehicle within the road, the intersections. Turn on, as you can see. This vehicle alarm will look like a red light alarm, which will buzz if ever a vehicle is approaching, and there are motion sensors. To the next one, as you can see, I only used one motion sensor for the intersection because it uses the same road. Whenever a vehicle is approaching downward or upward the road, it will just turn on. As you can see, the vehicle alarm will buzz. Same goes for the next intersection, and eastmost road. As you can see, the vehicle alarm will turn on, in which I have explained all their functions and their uses in my PowerPoint. So I'll go next to my next design, which is the street with one section. I'll just run similar test. So at first, I'll have the situation 1, which is daytime. Daylight sensor is at logic 1. No bulbs are turned on. Our situation 2 is it's nighttime. So this manual switch and power must be at logic 1, assuming there are no problems. Then the 16 bulbs will turn on. So next, you'll try to emergency lamp. What if there is a power outage? Emergency street lamp will turn on. So this is a substitute whenever there is a power outage, or just the output of these 16 lamps. They produce logic 0 in case if there is a break or a defect. This is a substitute for the emerging street lights. They have the emergency street lamps. And next, I'm gonna try my motion sensors again in this west side of the road. Vehicle approaching, the buzzer will turn on. So it just goes. And another to the east side, there's a vehicle approaching. The motion sensor will just turn on. So this is it for my logically design, and thank you. So welcome to my Tinkercad simulation. So as you can see, it is just a prototype, and the number of light bulbs are reduced at half its amount. So the alarms are still the same and the street lamps. So let's get on with the simulation. First, I'll just follow my logical simulation. First, we have the first situation, which is daytime, right? So we have this manual switch. It is always at logic 1. The power, assuming there's no power outage, also at logic 1. And this daylight sensor, since it is at the daytime, this daylight sensor will pick up light, and thus it will turn into logic 1. Its input, its output, it's the output coming from daylight sensor is logic 1. So therefore, as you can see, no bulbs are being lit. The bulbs outputs are logic 0. So that's it for the daytime situation. Next, what if it's nighttime? So this daylight sensor, it won't catch any more light, thus it will turn off. It will become logic 0. As you can see, the street lights, the bulbs, they turn on. They are at logic 1. So with this design, the manual switch, considering the switch is on, the no power outage, and it's a daylight sensor. So that's the first part of my design. So moving on to the second situation, and also the second part of my design, which is how these emergency street lamps activate. So what if there is a power outage? As you can see, no power is flowing through the street lights. Thus this, and therefore these emergency street lamps are being activated. As you can see, these are yellow LEDs. So it's just a prototype. So that's a representation of what's the actual project. So there are alternative lights so that the community, the area around the community is still has proper vision and night vision given by these emergency strip. So that's it for the lights. I'll move on to the motion sensor, wherein these are activated at the edges or at the intersections. So it is logic 1. If there is an approaching car, it will sense that a car is approaching. So as you can see, later, assuming there is power, it will work. The beep buzzer will work and it will emit a red light. The same is true for the other side of the road. When I turn on, the vehicle alarm buzzer will also turn on. So this is the road representation. As you can see, this is the edge intersections of a road with the only one section based on my logical design. So these are the vehicle alarm, at the edge it will display. It will benefit the people if there is a car incoming. So assuming there is power because it runs through electricity. So this is it for my prototype in Tinkercad. Thank you very much.